Welcome to MedhāVatika Marble Slides. Today we are going to use the power of algebra and coordinate geometry to solve some challenging puzzles. Our goal is to collect all the stars on the graph by launching marbles along a path we create using mathematical equations. Let us look at the first level. We start with a basic parabola. A parabola is a U-shaped curve defined by a quadratic equation. In its simplest form, it is written as y equals x squared. By changing the numbers in our equation, we can move the curve or change its width. Notice that in our first attempt, the curve opens upward, missing the stars. To fix this, we add a negative sign at the beginning of the equation. This reflects the parabola across the x-axis, making it open downward. To hit the stars perfectly, we need to adjust the width of the curve. By changing the coefficient of x squared from 1 to 4/5, we perform a vertical compression. This makes the parabola wider, allowing the marbles to pass through every star on their way down. In the next challenge, we learn about shifting the vertex. The vertex is the highest or lowest point of our curve. By adding or subtracting values inside the parenthesis, we can move the parabola left or right. This is known as a horizontal shift. Adding a number at the very end of the equation moves the whole curve up or down. Now we encounter a more advanced concept called domain restrictions. Sometimes we do not want the entire line to appear on the graph. By adding a condition in curly brackets, such as x is less than 7, we tell the computer to only draw the part of the graph we need for our slide. On the challenge slides, we are essentially building a piecewise function. This is a single path made up of several different equations joined together. By combining linear equations, which are straight lines, with quadratic parabolas, we can create complex paths that navigate around obstacles. Watch how precise adjustments to the slope and the vertex allow the marbles to flow smoothly from one section to the next. This shows how mathematical functions can be used to model movement and solve physical problems in a digital space. Great job on completing these levels. We have seen how transformations and domain limits can turn simple equations into powerful tools. There is much more to learn about these amazing curves. That is all for this session. There will be a part 2 of this video coming soon where we will tackle even more difficult levels and complex equations, so stay awaited for that.